Hello, calculus students and seekers of truth. Now we are going to look at some calculus as it relates to parametric curves. So we have this curve defined by these two functions. X and y are written in terms of t. Now, just so that we could see a little bit better, I've typed this into my calculator and I've graphed it. So we get an image that gives us an idea of what we have here for the curve. So I'm just going to draw this on my paper. And now also, if I choose the use the trace feature on my calculator, type in t equals 0, I get that x is equal to -3 and y is equal to 0. So basically that means this point here, I should call this -3, but in particular it is when t is equal to 0. And let's just try a few other points. Maybe t equals 1. Then x is equal to -1 and y is equal to +1, so that's like right here. Okay, so it basically tells us that the curve is being drawn this way, in this direction. Now it wants to know the slope of the tangent line of the graph of x and y. So it's not looking for the derivative in terms of x and y per se, in terms of x and t, but it's looking for the slope of the tangent line. So when it looks for dy dx, okay, when t is equal to 4. When t is equal to 4. Okay, so what is the derivative of y with respect to x when t is equal to 4? Okay. Now, so this is on the graph here. If I type in t is equal to 4, this is way off the screen. Let me adjust my window here. So y max. Let's go all the way up to 80. And there it is. So trace t equals 4. So in other words, at this point right here, what is the slope of that line? Now notice, we don't have a function of x and y in terms of each other. We have two separate functions, x in terms of t and y in terms of t. So in order to get dy dx, we have to first eliminate the parameter. And we're trying to get y here as a function of x. So in other words, y is the dependent variable. So we're going to solve this first equation here. It isn't too difficult to solve. So x plus 3 over 2 is equal to t. Right? And then we're going to take this result right here, and substitute it in for t. So what I end up getting is y equals x plus 3 over 2 to the third power. And then from that point on, I can take the derivative. Dy dx is equal to, and this is a good practice of the chain rule and some other rules that we may have used, 3 times quantity x plus 3 over 2 squared. Okay. Times 1/2. Almost forgot the chain rule there, because this is a x over 2, so it's really x times 1/2 plus 3 times. So x over 2 plus 3 over 2. So I need to multiply by that. So let's just simplify a little bit here. This becomes 3/2 x plus 3 squared. Right? And now from this point on, and notice here that I don't know I have a derivative here in terms of x, but I don't know what to plug in, at least not immediately, because I don't know what the value of x is. The question asks, what's the value of t? In other words, if this was a particle, at exactly 4 seconds, what is the change in y over the change in x of that particle's position? That's another way we could look at it. Okay. So in order to figure out what x is equal to, I have to substitute 4 into here for t. So when t equals 4, x is equal to 2 times 4 minus 3, which is 5. And so now dy dx, when t equals 4, that's the original problem that I'm being asked to solve, is the equivalent of dy dx when x is equal to 5. Because of this equation, we know that when t is equal to 4, x must be equal to 5. So now I can take this 5 and substitute it into this equation. And I get 3 over 2 times 5 plus 3 squared. Okay, so this is the 5 that I'm substituting. So that is 3/2 times 8 squared, which is 64. That's gone, that's gone. We're back down to 32. And our final answer is going to be 96. Okay. So in other words, when t is equal to 4, this curve is extremely steep. It has a slope of 96 units. So there it is, an example for us to, in order to find the derivative of a function in terms of x and y when we start out knowing only t. Now this process is a little bit tedious, so we are going to have to find a better solution in the next video.